Hello and welcome to this video on substitutions in type systems. So in the last video we looked at substitutions. This is where we have a substitution which is a set of mappings and we saw how they could be applied to strings. So here, for example, where we have a substitution that's just a set of the mapping h goes to j, we apply that to the string hello, while the h in there turns into j and we get jello. So that was substitutions. We're now going to see how we apply these to types. So what's the relevance of these substitutions to type systems? Well, Hindley-Milner has several different type inference algorithms. We'll get to know them later. They're often called algorithm W, algorithm M. There's other ones as well. But what's common to most of these algorithms is they use substitutions from type variables to monotypes. And we're going to apply these substitutions on types to figure out, hey, how do we infer the types? How do we unify the types? And we'll see exactly how we do that in a bit. But just know that these substitutions on types are going to be really useful for us in defining and using the type inference algorithms. So what might this look like? Just as we had a substitution from one string to another, here we've got a substitution from a type variable to, in this case, a monotype. In particular, this is a type function application. Remember that int is a type function application with 0 arguments. If we have a type such as this, so here we've got alpha to goes to bool, we apply this substitution on here. Well, we're replacing all the alphas with ints, so we just get int to bool. Hopefully that makes sense. Also, we've got to remember the rule that they're all applied simultaneously. So let's have another example. Here we've got a substitution of alpha to goes to beta and beta goes to int. We've got 2 examples here. What happens if we apply this substitution on alpha goes to beta? Well, in this case, we get beta goes to int. Well, why is that? Well, because the alpha gets mapped to the beta gets mapped to the int, and they're done simultaneously. So it's not the case that the beta then gets mapped to the int. If we applied the substitution again, yeah, we'd get int to int because we're effectively applying that substitution on beta to int. And the only thing there to get mapped is that type variable beta, which gets mapped to int. We get int to int. Hopefully that's been a good introduction on how we use substitutions on these types. Remember, in Hindley-Milner, we're going to use these in our algorithms, algorithm W, algorithm M, as part of our type inference algorithms. What our substitutions in Hindley-Milner type inference are going to do is going to map from type variables to monotypes for us, okay? And we've seen here with some examples how that looks, how they get applied. Thanks for watching, and see you in the next video where we get to learn how we combine substitutions.